So in today's class, we are going to discuss about Euler's totient function or Euler's pi function. Now, this particular topic is not given in JEE advanced syllabus, but this can be used as a tool to solve problems, because nowadays JEE people are little bit inclined towards number theory. Totient function is one of them. In this year only, I will show you at the end of this class that a problem came in JEE 2025 which can be easily solved by using totient function. If you don't know the totient function, then also you can do that problem. That's not the question. The question is, the way these people are giving problems tomorrow, they can give a number which is little bit higher than the number which is given in this exam in 2025. In that case, Euler's totient function will be the only way to solve that problem. So it is always better to learn the method or this tool in beforehand. Okay, so let's start today's class. What is Euler's totient function? First of all, we must know that first there is a little declaration. That is, whatever we will talk here is all your natural number. All are natural number. Okay? All are natural number. Now, what is Euler's totient function? It's a very, very simple function, but a very powerful tool at the same time. We denote this Euler's totient function by phi n. What is phi n? N is, again, I'm telling you, I've already said that n is a natural number. This I will not say anymore. You should always know that whatever n we are talking about the natural numbers. Now, what is phi n? Phi n actually represents the number of numbers which are less than n. Like, if I say what is the totient function of, say, 7, it means what are the numbers there are below or equals to 7. That is, what I'm saying is, your totient function gives us the number of numbers which are less than or equals to 7. Okay? But this is not the end. The number, whatever you are choosing, the number which are less than 7 or equals to 7, the number, and in this case your 7, their GCD should be equals to 1. Their GCD or HCF, whichever way you say, it is always 1. That is, the number that you are choosing which are below 7, they are co-prime to 7 in this case. In general, we can say whatever number we are choosing, the GCD or HCF of that number and n, that equals to 1. That is, the number that you have chosen which are less than or equals to 7, in this case it is n and that number, they are co-prime to each other. Is it clear? Now you have to find out the number of numbers that are below n or equals to n, whose GCD is equals to 1 with that number. Like, if I ask you, what is your phi of 7? Now, what are the natural numbers which are below or equals to 7, whose HCF with 7 is 1? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. 7 and 7, they are not co-prime to each other. Therefore, your phi of 7 directly you will write the answer is 6. That's it. Is it clear? Suppose if I say, what is phi of 6? So you will say the numbers can be 1, the number can be 2, cannot be because 2 and 6, they are not co-prime to each other. 3, no. 4, no. 5, yes. 6, no. So what is your phi of 6? Your answer is 2. That's it. That's all about your Euler's Totient function. It is represented by phi n, and you have to find out the number of numbers which are less than equals to n such that that number and n, the GCD of these two numbers will be equals to 1. That's it. Okay, now suppose if we have given phi of AB, this is the first formula that you must remember. Phi of AB can be written as phi of A into phi of B. That is what I want to say. Suppose if I say, what is the Totient function of, say, 10? Let me first do it analytically. What is phi 10? It can be 1, 2, no, 3, 4, 5, 6, 7, 8, and 9, right? So there are 4 such numbers. Now let us try to find out by using this formula. What is phi 10? Phi 10 can be written as phi of 2 into 5. So which can be written as phi 2 into phi 5. Okay. Now what is phi 2? The numbers which are less than 2 and co-prime to 2, that is only one number is there, which is 1. And what about pi 5? The numbers which are less than or equals to 5 and co-prime to 5. So they can be 1, 2, 3 or 4. So it will be 4. So the Totient function of 10 is nothing but 4, which we already got. Is it clear? So the first formula that we will remember is phi of AB can be written as phi of A into phi of B. Number 2, phi of any prime. Let us say n is a prime. N is prime. If n is prime, then the Totient function of n will be nothing but n minus 1. Like, what is your phi 7? It is 6. Because 1, 2, 3, 4, 5, 6. So there are 6 numbers. But 7 is a prime number. So phi of 7 or any prime number, it is equals to that prime minus 1. Number 3. If suppose we have been given a to the power n. A to the power n. So the Totient function phi a to the power n will be a to the power n minus a to the power n minus 1. Like if I say, what is phi of 8? We all know that phi of 8 will be 1, 3, 5 and 7. So there are 4. So what is the Totient number of 8? It is 4. Now let us try to do it by this method, 2 cube. This can also be written as, according to the formula, it will be 2 cube minus 2 square. So 2 cube is 8 and 2 square is 4. So that gives us 4. So phi of a to the power n is a to the power n minus a to the power n minus 1. So these 3 formulae we have to remember. Is it clear to everyone? Absolutely. Okay. Here a is a prime. A belongs to any prime number. Okay. Phi of a to the power n, a is always a prime. Otherwise this formula will not hold. If I say that what is phi of, let us say 6 square. So in this case, if you write it is 6 square minus 6, then it will be wrong. Why? Because 6 is not a prime. So whenever you are using this third formula, always remember that A is your prime. Is it clear? Now we will move for what is the application of this Euler's Totient function. A very important application of this is finding out the remainder. I will show you how. The question is, find the remainder when 2 to the power 100 is divided by 101. Now, how to find out the remainder by using Totient function? Remember one thing. Let me write it here. It's an important note. If I say that a number, let us say A, is divided by M, the remainder will be 1 if the power of A is the Totient number of M. But remember one thing here, A and M are co-prime to each other. The greatest common divisor is 1. That is, A and M are co-prime to each other. If it is so, then A to the power Totient number of M is congruent to 1 modulo M. Very, very important theorem to be used to find out the remainder. Now you observe one thing in this, as I told you in my previous lectures on number theory, that all of the mathematicians, they have worked on how to bring 1 in the remainder. So Euler's Totient function is also used to bring 1 as the remainder when the number is divided by M. Have you seen? So always remember that if A and M are co-prime to each other, then A to the power phi M is the Totient number of M, is congruent to 1 modulo M. Let us consider the first case. The question is, what is the remainder when 2 to the power 100 is divided by 101? Now straight away I will see that your 2 and 101, they are co-prime to each other. Now, what is the Totient number of 101? 101 is basically a prime number. So as I told you, the formula that for any prime, the Totient number of that prime number is P minus 1. So in this case, the Totient number of 101 is nothing but 101 minus 1, that is 100. Therefore, 2 to the power 100 when divided by 101, the remainder is 1. That's it. Is it clear? So directly we got the answer that the remainder of 2 to the power 100 when divided by 101, it is nothing but 1. Is it clear? Let's see the next question. I'll see the second question. It says that find the remainder when 2 to the power 53 is divided by 24. But here we cannot use Totient function. Why? Because 2 and 24, GCD of 2 and 24, this is not equals to 1. So if I want to use the Totient function, we have to, as I told you, the only condition of applying Totient's function is that the dividend and the divisor, the base of the dividend and the divisor, they should be co-prime. But in this case, 2 and 24, they are not co-prime to each other. So how to use Euler's Totient function in this case to find out the remainder? So what I'm doing is, you see, for 24 we can write, this is 8 into 3, so that gives us 2 cube into 3, so that gives us 2 to the power 50 divided by 3. Is it clear? So what I've done, I have simply cancelled 8, from the numerator as well as from the denominator. That is from the dividend as well as from the divisor. So as I told you in my previous classes on number theory, that whenever you are cancelling any term from the dividend as well as from the divisor, whatever remainder you are getting after simplifying that should be multiplied with that scalar to get the actual remainder. I have already discussed them in my previous two videos. So those who have not seen it, they may not understand what I am saying. I will say, please do see that two videos. Link has been given in the description box. So in this case, we can find that our GCD of 2 and 3 is 1. That is 2 and 3, they are co-prime to each other. And the Totient number of 3 is 3 minus 1, that is 2, because 3 is a prime. So we can write that when 2 to the power 2, the Totient number of 3, when divided by 3, the remainder is 1. Now we can easily see that 2 square, we have to reach to 2 to the power 50. So straight away what I will do, I will simply raise its power to 25. Still the remainder will be 1. So 2 to the power 50, when divided by 3, the remainder is 1. But now the answer will not be your 1. The remainder is not 1. In this case, the remainder is 1. But you have already cancelled 8 from the dividend as well as from the divisor. So that you have to multiply to get the final answer as the remainder when 2 to the power 53 is divided by 24 is 1 into 8. That gives us 8. Is it clear? So 8 is your correct answer for this problem. Is it clear to everyone? Absolutely. Okay, let's move for the next problem. See this question. What is the remainder when 3 to the power factorial 65 is divided by 80? Now, is your GCD of 3 and 80 equals to 1? Yes. Therefore, 3 and 80, they are co-prime to each other. And what is the Totient number of 80? So 80 can be written as 5 into 16, right? Which is actually 2 to the power 4 into 5. As I told you that phi of AB can be written as phi of A into phi of B. So in this case, we can write this thing as phi of 2 to the power 4 into phi of 5. Now, 5 is a prime number, so it will be 4. I know the formula that for any prime, the Totient number is p minus 1. And for 2 to the power 4, 2 is a prime. So 2 to the power 4, the Totient number will be 2 to the power 4 minus 2 cube. So we are having 16 minus 8 into 4. So 32. Therefore, the Totient number of 80 is 32. So what we can write? We can write 3 to the power 32. And 1 is congruent modulo 80. Is it clear? That is 3 to the power 32. When divided by 80, the remainder is 1. But we have to go for factorial 65. So what I'm doing is, I'm simply raising its power, because you can raise its power to any extent. Because in that case, your remainder will still remain 1. So that advantage we people are always taking. So I'm simply raising its power to 65, 64, 63. This thing goes on till 33. Then 32 I will not write. Then again I will start with 31, 30, 29, and this thing goes on till 2, 1. Still the remainder is 1 modulo 80. Right? Now, what is that power? What is that exponent? It is basically 3 to the power factorial 65, which is 1 is congruent modulo 80. Therefore, 3 to the power factorial 65, when divided by 80, the remainder will still be 1. Is it clear to everyone? Have you understood this clearly? Okay. So let me take another example. See this question. Find the last 2 digits. It's another application of Totient form. Find the last 2 digits of 41 to the power 937. Okay? So how to do this? We know that to find out the last 2 digits, you have to find out the remainder of any number when divided by 100. Am I correct or not? Suppose if I say, what is the last number of 103562? We all know that it is 62. But how will understand mathematically how we will say? We will say that when this number is divided by 100, the remainder will be 62, which is nothing but the last 2 digits of that given number. Is it clear? Now we have to find out the last 2 digits of 41 to the power 937. That is, we have to find out what should be the remainder when this number is divided by 100. Is it clear? And that eventually will give us the last 2 digits of this number. So do that. Let me just find out what is the Totient number of 100. This is basically 25 into 4. So that gives us 2 square into 5 square. So that is basically 5 of 2 square into 5 of 5 square, which is 2 square minus 2 into 5 square minus 5. So that gives us 2, and here it is 20. So it is coming to 40. Am I correct or not? Is it clear? Therefore, the Totient number of 100 is 40. And GCD of 41 and 100, that is 1. They are co-prime to each other. Therefore, we can write 41 to the power the Totient number of 100, which is 40. And 1 is congruent modulo 100. Is it clear? But we have to reach to 41 to the power 937. So I am simply raising its power to 23. So it is again 1 modulo 100. And 14 to 23, that gives us 41 to the power 920. And 1 is congruent modulo 100. So now we have reached till 41 to the power 920. But we have to reach to 937. So what to do? It means that if I multiply both sides with 41 to the power 17, then we are going to have 41 to the power 17 modulo 100. And this gives us 41 to the power 937 is congruent to 41 to the power 17 modulo 100. So our question has been boiled down to what is the remainder when 41 to the power 17 is divided by 100. That's it. 41 to the power 17. Our problem has been reduced to when 41 to the power 17 is divided by 100, what is the remainder? That's the question now. It has been reduced to this form. So for that, you have to understand one very, very important relation in prime numbers. I've done it in the next page. See this one. Very, very important thing. You have to only remember that this series you have to remember, and it is always in a cycle. 81, then 61, then 21, then 41, then again 81, 61, 21, 41, and this thing goes on repeatedly. What do you mean by that? I'm telling you. Let us take any prime. I have taken here 4 primes. One is 11. 11 square is 21. The moment you get that, you use this cycle. You raise its power to 2, and the last 2 digits always run in this cycle. 11 squared, the last 2 digits is 21. You check it. 11 into 11 is 121. So last 2 digits is 21. Where is 21? Here it is 21. Now simply you raise its power to 2. That is 11 to the power 4. The last 2 digits will be 41. Now again you raise its power to 2. That is 11 to the power 4, then whole square. So it gives us what? 11 to the power 8. Now the last 2 digits will be 81. If you raise its power to 2 again, then the last 2 digits will be 61. Are you getting the point? That's exactly what I have written. And again, if you raise its power to 2, that is 11 to the power 32, the last 2 digits will be again 21. And this thing goes on. Same thing with 13. You check it. 13 to the power 4 is 61. 61 is where? Here it is 61. Then according to the cycle, if you raise its power to 2, that is 13 to the power 8, the last 2 digits will be 21. Now again you raise its power to 2, that is 11 to the power 16. The last 2 digits will be 41, and this thing goes on this cycle. So 81, 61, 21, 41. Again 81, 61, 21, 41. This thing goes on repeatedly. So for any prime, let us consider about 41, because we are actually doing, we have to find out the power, the last 2 digits when 41 to the power 17 is divided by 100. So we are interested in 41. You see, 41 square, the last 2 digits will be 81. 41 to the power 4, 81 is here. 41 to the power 4. The last 2 digits will be 61. Again you raise its power to 2. So 41 to the power 8. The last 2 digits will be 21. Again you raise its power to 2. That is 41 to the power 16. The last 2 digits will be 41. And this cycle goes on repeatedly. Getting my point? So this is a very important conception you must remember, and it is true for all primes. All primes. First of all, if you have been given any prime, you first make it square and only see whether anything out of 81, 61, 21 or 41 is coming or not. If you maximum, it will take that prime to the power 4 will give you one of these 4 numbers. In maximum cases, if you square it, you are going to have that number. If you don't get that number, any number from this 4, 81, 61, 21 and 41, if you don't get it, you simply again square it. You are definitely going to get any of these 4 numbers. The moment you get that 4 number, you find out the location of that number in the cycle. And then you raise its power, move to the another one. Raise its power to 2, move to the another one. And this thing goes on. Is it clear now? So 41 square is basically 81. Now let us come back to our problem. It is 41 to the power. Let me write it there. We are actually concerned about what is 41 to the power 17, right? 41 to the power 17. I have to find out what is the remainder when it is divided by 100. That is the last 2 digits we are interested for. Now, we all know that 41 to the power square, 41 square is 81. So we got that number. Now, 41 to the power 16, as we have calculated, the last 2 digits will be 41 again. Yes or no? So, 41 to the power 16, when divided by 100, the last 2 digits is 41. But we have to reach to 41 to the power 17. So it will be 41 to the power 16 into 41, which gives us 41 square modulo 100. Now 41 square, if you divide it by 100, what is the remainder? Or you can say, what is the last two digit? It is 81. Am I correct? Therefore, 41 to the power 17 and 81 are congruent modulo 100. Am I correct or not? So here we got that 41 to the power 937 and 41 to the power 17 is congruent modulo 100. Right now we got 41 to the power 17. When divided by 100, the remainder is 81. Therefore, 41 to the power 937 when divided by 100, the last two digit will be 81. That's it. That's your answer. Is it clear? So in this case, we have learned a very important thing, very important thing, which is this one. So always remember, this is my observation. I have not seen it in anywhere, neither in any book nor in any videos. So this is my observation. I have found that for any prime, if you raise its power to 2, your maximum 4, you are going to get one of these values, 81, 61, 21 and 41. The moment you get that, you simply run this cycle to get its exponent, multiple of 2. Okay? So I hope this part is also clear. Okay? So we have learned two applications of Totient number. One is to find out the remainder, and next one that we have done is to find out the last two digits. Now I will show you the sum that came in this year JEE Mains 2025. See this question. Here a set A is given, which is 1, 2, 3, 4 till 10, and B is another set which is m over n. And the condition that they have given is m is less than n. And m and n you are choosing from set A. But here is a big hint for using Totient form. Again, in the beginning of the question, I told you, if this question, particularly this question which came in this year, 2025, in JEE Mains, you can solve it by, if you don't know Totient, Euler's Totient function, still you can do this sum. But if the number is higher, you will face problem doing the sum. That is the reason my motto is to teach you this Euler's Totient function. So GCD of Mn is 1. The question is, how many number of elements are there in B? If you don't know Euler's Totient function, you have to do it manually. First, let me just write it here, n. So first I will take n is 2. If n is 2, your m can be 1. Only 1. N cannot be 1. Be very careful. Your n cannot take 1 because here m is less than n. So in that case, if you take n as 1, you cannot choose m. So that is why your n has to start from 2. Now, if n is 3, your m can take 1 and 2. That is 2 values are there. If m is 4, we have to choose the value 1. I cannot choose 2. Why? Because 2 and 4, the GCD is not 1. That is, they are not co-prime to each other. So I will take 3. So again, it is 2. And this thing, we have to calculate it manually. But one who knows the Euler's Totient form, he will simply write, yes. What I will write? I will write your n can take 2 or 3 or 4 or 5 or 6, 7, 8, 9 or 10. So when it is 2, you have to choose m, which are co-prime. I mean the numbers which are less than 2, but it is co-prime to it. So we have to actually finding out phi 2. Here it is phi 3. Here it will be phi 4. It is phi 5, phi 6, phi 7, phi 8, phi 9 and phi 10. Okay. Now it is very easy to calculate. Don't think that, sir, it will be a very long to calculate. No. Try to think if you don't know Euler's Totient form, then you have to calculate each and every one. But here you have the formula. Euler's Totient function, you have the formula. So we can directly use it and we can get the answer very quickly. Check it now. Phi of 2. It is 1 because 2 is a prime. So it will be what we have learned. For any prime, the Totient number is p minus 1. So for phi 2 it is 1. For phi 3 it will be 3 minus 1, that is 2. For 4 it will be 1 and 3. So it will be again 2 numbers. What is phi 5? Phi 5 is an prime number. So it will be 4. Phi 7 it will be 6. No more prime numbers are there. So now what is phi of 6? Simple. It's phi 2 into 3. So it is phi 2 into phi 3. Phi 2 is 1. Phi 3 is prime. So phi 3 will give us 2. So it is 2 only. So phi 6 is nothing but 2. What about phi 8? Phi 8 is basically phi 2 cube. So 2 cube minus 2 square. That is 8 minus 4. That is 4. So this is 4. What about phi 9? Phi 9 is phi of 3 square. Can be written as 3 square minus 3. So 9 minus 3, that gives us 6. What about phi 10? It's phi 2 into phi 5. Phi 2 is 1 and phi 5 is 4. So it is nothing but 4. So if you simply add this, you are going to get the number of elements in set B. Isn't it so? Okay, so let me just add it. 5, 4, 9, 11, 17, 21 and 10, that gives us 31. And that's your answer. Is it clear to all? Is this session clear to everyone? So Totient function, Euler's Totient function is a very important tool. You must know it. As I told you in the beginning of this class, that IIT people, they are now little bit more or less, they are inclining on your number theory. Tomorrow they can simply raise this number to a very large one. So in that case, manually you cannot find it. Analytically you cannot find that. So in that case, you have to take the Euler's Totient function help. So I hope you have enjoyed this class. So see you tomorrow. Till then, take a very good care of yourself.